everyone, my name is Chaton. I'm PyTorch Lightning Research Engineering Manager, and today I will talk about our latest innovation with PyTorch Lightning. I will start the presentation talking about Lightning APIs, and I will move to Lightning features and finish the presentation with our latest innovation. So as a researcher, you want to iterate on research quickly, but most of the time is actually spent on deep learning engineering, not the proper research. And I can't agree more with this statement. As a matter of fact, I created my own deep learning framework for point clouds 2 years ago and spent countless hours working on engineering-related issues blocking my research. When I met William Falcon, PyTorch Lightning creator and Grady ICO, I shared with him my frustration about how complex and difficult it was to get the engineering right. He laughed and told me it was exactly why he created PyTorch Lightning, a lightweight PyTorch wrapper for high-performance AI research with a crystal-clear mission. We do the hard engineering work so our users don't have to. To enable this, Lightning created a stable API enabling flexibility and reusability. It makes our user platforms more modular and interoperable at scale. Our API is made of the following components: the Lightning module, which encapsulates your model, the Lightning data module, which encapsulates your transform, dataset, and data loaders, the trainer, which takes care of all the hard engineering behind the scenes. The callback are a way for people to customize Lightning using hooks. Torch metrics, our newly released library, it makes it easy to develop and use new metrics in plain PyTorch and with PyTorch Lightning. And Lightning accelerators, which allow custom integration in the trainer internal, such as custom distributed data parallel implementations. The Lightning module decouples the model code into its own components. It improves readability, and it's actually easy to convert from plain PyTorch. The model instantiation should be placed within the init. It's also good practice when you use Lightning to lift model to enable faster conversion from plain PyTorch. The training, validation, test, and predict steps are respectively being called in training, validation, test, and predict loops. The configure optimizers hook return optimizers and LR schedulers to be used during the training. More importantly, the Lightning module is device agnostic, making your code much more readable. The Lightning data module decouples the data loaders into its own components. It improves readability through a standardized API. The train, val, test, and predict data loaders hooks should return the data to be used within the respective loops. By both using the Lightning module and the Lightning data module, it makes your code more reproducible. The trainer provides a simple interface with 50+ features which reduce boilerplates. Once you have organized your PyTorch code into a Lightning module and a data module, the trainer automates everything else. You can easily fit, validate, test, and predict your model on your data with or without distributed settings. This abstraction achieves the following. First, you maintain full control on all aspects via PyTorch code without unadded abstractions. Also, the trainer uses best practices embedded by contributors all over the world and users from top AI labs such as Facebook AI Research, NYU, MIT, Stanford, and many more. The trainer allows overriding any key parts that you don't want automated. A callback. A callback is a self-contained program that can be reused across projects. The user can override any hooks to customize Lightning to its needs. Lightning has a callback system to execute callback when needed. Lightning provides some essential ones such as early stopping or model checkpoint. Here's an example with a callback to print metrics within a table at the end of an epoch. First, the callback overrides on epoch and hook, where it accesses the callback metrics from the trainer, formats them into a table, and prints them on ring 0. Callbacks can easily be provided to the trainer, enabling functionality encapsulation and high customization. Moving to metric. The metric API provides updates, compute, reset, and functions to the user. The metric base class inherits from PyTorch NN modules, which allows us to call metric directly to perform an update. Compute is meant to be called on epoch end, and the internal state will be synchronized and reduced across processes automatically when running in the distributed settings. Lightning recently released metric as a standalone library called Torch metric, offering 25+ rigorously tested metrics through a class and a functional API. Here's how it works with the accuracy metrics. In init, call the add state to register internal states. We register correct and total as tensors. In the update function, increment total with the batch size and correct with the number of correct predictions. Finally, in compute, return the ratio between correct and total. Lightning accelerators. Lightning accelerators are actually a very strong component within Lightning. After a complete refactor of Lightning accelerators, it is now easier than ever to extend a new training paradigm to Lightning. As an analogy, the trainer is Lightning brain, the loops are Lightning nervous and broad system, and accelerators are actually, and plugins are actually like Lightning muscles. As a matter of fact, we recently added DeepSpeeds 02 and 3 from Microsoft, sharded, fully sharded, and model parallelism from Fairscale Facebook, and SMDP from AWS SageMaker in just the past 2 months. So the trainer is responsible for holding the loops, train, val, test, and predicts, and the accelerators, which handles the hardware, such as CPU, GPU, and TPUs. The loops and the accelerators communicate through the trainer. The accelerators also encapsulate the plugins. We currently have 2 types of plugin: Precisions, which contains FP32, IMP, FP16 for TPUs, and training type plugins, which enable us to extend for new training paradigm into Lightning, such as DDP, DP, DeepSpeed, and many more. And the clusters environments, such as Slurm and Torch Elastic, are encapsulated within the training type plugins. So when you convert from plain PyTorch to Lightning, you already get an exhaustive list of features on top of PyTorch. One of them is distributed training, and Lightning makes it extremely simple to deal with. Here's how you can use 1 GPU with Lightning. Here's how you can scale your training to 8 GPUs with Lightning. And here's how you can train with 256 GPUs on Lightning by providing 32 nodes and 8 GPUs. Lightning provides multiple accelerators, which can be used without no-count change, and it makes it easy to experiment. Lightning supports Override, DeepSpeed, DDP Spawn, DDP, and many more. Lightning comes with an automated version checkpointing system through the model checkpoint callback. Lightning also has built-in support for most of the command loggers out there, such as TensorBoard, 1DB Logger, Comet, MLflow, and Neptune. So you can always track your logs of your experiments. Lightning also provides profiler to find bottlenecks. And more importantly, Lightning is being tested on multiple operating systems, several Python and PyTorch versions, and on multiple hardware, such as CPU, multiple GPU, TPUs, multi-node, multi-GPUs. So when you use Lightning, you can be pretty sure that the areas that Lightning automates for you are extremely well tested. And when you use Lightning, you also get many, many more additional features, such as accumulated gradients, gist export, Onyx export, truncated backpropagation, and so on. So moving to the exciting things, our latest innovations. We added some new callbacks within Lightning. We finalized the DeepSpeed integration. We added support for PyTorch 1.8.1 Kineto profiler. We added a Lightning client, which makes it simpler to move from plain PyTorch to Lightning. And Lightning Flash, our latest open source framework. So the first callback is base fine-tuning. Base fine-tuning callback provides a simple API to quickly experiment fine-tuning strategies with no code change to your Lightning module. Simply overrides the freeze before training and fine-tune function with your own custom logic. Here on the right, you can see the milestone fine-tuning callback. In the freeze before training, we actually freeze the weights of the backbone. In fine-tuning function, when reaching the first milestone, we will unfreeze the 5 last layers of the backbone and pass them as a new param group to the optimizer. When reaching the second milestone, we will unfreeze the remaining layers of the backbone and pass them as a new param group to the optimizer. So it's very simple for you to experiment with new fine-tuning strategy. Lightning also provides techniques to compress model size for deployment, allowing inference speed and energy saving without significant accuracy loss. Pruning through model pruning callback is a technique which focuses on eliminating some of the model weights to reduce the model size and decrease inference requirements. Quantization aware training is a quantization technique that allows speeding up inference and decreasing memory requirements by storing computation at a lower bit width, such as int8 or float 16. Stochastic weight averaging is a technique that can make your model generalize better at virtually no cost. The SWA procedures move the loss landscape, thus making it harder to end up in a local minimum during optimization. The SWA procedure consists to average the weights from the latest epochs and then update the batch normalization statistics. While working on DeepSpeed integration, DeepSpeed integration is actually a framework from Microsoft, which enables to scale models to up to 1 trillion parameters. We actually managed to scale Andrew Carpati MinGPT to 45 billion parameters while training on a Lambda A100 8 GPU. You can learn more within our Medium article, Accessible Multi-Billion Parameters, Model Training with PyTorch Lightning and DeepSpeed. To use DeepSpeed within Lightning, you can just provide plugins equal DeepSpeed as a string, or you can import the DeepSpeed plugin from PyTorch plugins and play with the parameters to find the combination which fits the best your training. By providing profiler equal PyTorch, you will be able to use PyTorch latest Kineto profiler to find bottlenecks within your models. The profile traces can be visualized directly with Chrome tracing or within TensorBoard with a PyTorch AutoGrad plugin. As a nice caveat, VS Code now supports TensorBoard too. Lightning clients provide a simple API to generate rich help, and it's easy to make composition with it. Using classes directly, the Lightning clients will auto-generate description within your terminals. Using --printconfig, the Lightning client will generate a YAM file, enabling you to inspect all the possible arguments with the defaults. Using -age, the Lightning clients will generate a rich help descriptions within your terminals using the type annotations and the docstring within your class. This will actually enforce researchers to document the code to ease new user journey when using the frameworks. Moving to Lightning Flash. Lightning Flash is a collection of PyTorch Lightning tasks for fast prototyping, baselining, fine-tuning, and solving problems with deep learning. We currently support image, text, and tabular classification, object detection, image embedder, and summarization and translation, and we encourage the community to add many more. To work with the task, here you will import from Flash Vision the image classification data and the image classifier. After downloading some data, you can directly create a data module using some of the helper functions. Then you will create the image classifier by providing the number of classing and the desired backbone. Then you will create the trainer and fine-tune the model by defining the fine-tuning strategy. Currently, the Lightning API has been pretty sparse concerning data processing, and this has been a blocker for some engineers to make processing reusable and quickly ship models to productions. We have been experimenting with new APIs, and today we present a beta API for data processing through data pipelines, which are built out of a pre-process and post-process API. Built on this data processing abstraction, Flash callback extend Lightning wants to profile the transform data. Therefore, Flash introduced also a batch visualization callback used to investigate complex data transforms. We also introduced a backbone API within Flash. So why a data pipeline? First, let's go through the challenges. We're using data processing code is actually a pretty complicated task right now. And like we can see a pretty big screw between training and serving. And there's also some issue of interoperability when scaling models and frameworks. So the solution which we have been working on is the data pipeline. It's a standardized API for data processing. It contains specialized hooks for different stages, and it makes data part of the model. So the first object is preprocess. The preprocess provides processing hooks which organize the data processing logic. It makes it easy to quickly experiment with data augmentations, and you can wrap a data set if needed. All of this basically encapsulate all this logic into one component. Any hook can be made custom by adding a prefix. So here we have the load data hook from the preprocess, which has been made specialized to the training by adding the training prefix. Also, any hooks knows about the trainer stage through some booleans directly within the functions. By combining both approaches, the data processing logic can be made very thin and readable. Moving to the post-process objects. The post-process contains several hooks such as PyTorch transform, PySample transform, and uncollate, which will be applied on the predictions. It also contains some export logic. Flash also introduces some visualization tools. To make this possible, you can just import base visualization from Flash, then create your own callback, provide it to the data module, create your data module, and then do data module show train batches or show val batches to actually visualize a batch of data. Here on the right, you can see the output of such things. You have load samples, which are just individual loaded images, then the output of collate and the PyTorch transform. Lightning Flash also provides a backbone API with 400 plus available modules. By doing image classifier available backbones, you can see all the available ones. And it's actually pretty easy to use. By providing the backbone with the string you actually choose, this will create the model as desired. You can check out PyTorch Lightning and Flash docs for more information. We're also creating a Lightning community survey, and we encourage the community to provide us feedback. I take this moment to deeply thank and share my gratitude to our worldwide community of 400 plus contributors for the effort and hard work. Thank you for your attention.
Thank you, Thomas. So we had a few questions that came in prior to the event and during your session. One of the questions were, how can I serve PyTorch models to cloud and edge environments using this platform?
Yeah, great question. So Lightning actually provides several tools to export modules. One of them will be to export model to a JITable format or using Onyx export. Then cloud providers such as AWS actually contain some tools such as Neo, which will be used to export the models directly for, let's say, JSON cards. So that could be a way to do such things.
Awesome. Next question is, how did DeepSpeed manage to scale the model size to 45 billion parameters?
Yeah, great question. So DeepSpeed is actually relying on sharding. So sharding is a technique where you chunk the parameters of the modules and give the responsibility of those parameters to each of the GPUs. So the more GPUs you have, the smaller will be the shard on each one of the GPU. And by doing so, you can actually scale the model to up to 1 trillion parameters.
Awesome. Can you give a primer of motivation behind building PyTorch Lightning for those who are not aware about the basics?
Yeah, I will say, so when I started to use Lightning, what I was really surprised about was first how simple it was to convert from plain PyTorch to PyTorch Lightning. And the second part was really all the features that Lightning provides to the users. So when I was starting and iterating from my framework, I actually ended up like creating my own trainer, creating like my own logic around schedulers and so on. And that's really hard to do properly. So I think what I like the most with Lightning is all those things are extremely well tested. So when you use them, you can be pretty sure that everything is working as expected. And the community are actually like made of a lot of top AI researchers. So you can be pretty sure all those things work as you wish.
Awesome. Next question. What's the best way to learn PyTorch Lightning in depth?
Yeah, so we have some tutorials on the GitHub from Lightning. So a couple of examples just to get through how to quickly go through like the simple tasks, such as using convolutional neural networks on means, for example, or CIFAR, how to use like a ResNet with Lightning and so on. We also have a lot of examples within the docs, and the other library, which can be a good way also for people who don't really know too much about AI, but just want to have like a high level view is Flash, which is really like task-based things.
Awesome. Is it possible to do distributed training using GCP?
Yes, definitely. So you will just have to create an instance with multiple GPUs, and by just running Python.train and your script and just saying within the train of Lightning, I want to use, let's say, like 4 GPUs, which is the number of GPUs available within the instance, you will be able to do distributed training on GCP.
Awesome. We're going to take a few more questions, Thomas. How can anyone contribute to PyTorch Lightning? Like, what would be the advice for sending GitHub PRs?
Yes, that's actually a very good question. So there's several ways. I will say like the first one for people who have never been like who have never done any contribution to open source project, like a good place to start is usually the docs. Like you will always find like small typos or anything which kind of doesn't look right. So you can just open a quick PR updating the docs and you will get the first review. So that's like just getting you on the onboarding process of actually making your first PR to an open source project. Then you can look at the issues, and Lightning team actually labels issues. So you like going and filtering through the labels, you will see like good first issues, and those are usually issues which can be solved with not too much effort, and we try to leave them to the community to kind of getting onboarded. So you just clone Lightning, you try to solve the issues, and then you open a PR, and the team will definitely help you out to kind of grow your knowledge on how to do this properly.
Do you have any lightning.hub akin to torch.hub where people can share various model implementations and tricks? The community will then benefit from one another's experience at a faster pace.
So we don't actually have a model up for say, but we are working on creating somehow we're already working on trying to create such infrastructure for our users.
Okay. How does PyTorch help in data scanning applications?
Can you provide more details on data scanning?
We'll ask Roman to provide more details. Go to the next question. Is it tough to keep Lightning up to date with changes in PyTorch itself, i.e., I don't want to learn an extra layer if it diverges?
So the API of Lightning is actually final, so we are not going to change it, and we work very hard to make sure that every time we release a new version of Lightning, everything is backward compatible. So when you get into Lightning, you will go quickly through, and if you know like PyTorch and this concept of NN modules and so on, like it's actually pretty fast to get into Lightning. So I don't think that should make anyone afraid because as I said, everything is really final within Lightning.
Okay, and the last question is, and the other questions, anybody that's asked, we have your email address so we could answer them directly after. What are some of the examples of companies who are using PyTorch Lightning, and will using Lightning make PyTorch obsolete?
I would say maybe like the best example of a company who uses Lightning is Facebook. They have been working on trying to use Lightning more to make the platform more interoperable at scale. So this is like actually a very good article from Facebook on how Lightning is making that simpler. And I definitely encourage people to have a look.
Awesome. Thank you, Thomas, for answering everybody's question and a great session today.